Okay, so I'd like to thank Bella, Clarice, Raiden, and Sanvi for giving me the answers before 5 o'clock. If you have submitted your answers after 5 o'clock, then your name will not be here, all right? Because I need to prepare, right, for the answers. As in, I need to look through your answers, all right? I need to copy and paste into the PowerPoint slide, so it takes time. All right, so let's just go straight to the first question. Now, even though examination is over, please still pay attention, because whatever you're going to learn today, you are going to get tested in primary 5 next year, as well in primary 6 PSLE. So PSLE primary 6 examination will test you on P3, P4, P5, P6, all the science topics. All right, so whatever you learn in P3, P4 will also be tested next year in primary 5 exam. All right, Kim took an ice cube from the freezer, all right, and then put it into the bowl. Okay, she left the bowl in the refrigerator. She left it on the kitchen table for an hour and then placed it in the refrigerator. So the temperature of the ice and water are recorded. So for this question, those of you who submitted your answers, well done, you have gotten it correct. So for such heat question, you always do the HL, all right, higher temperature and lower temperature. So always remember, temperature always flow from higher temperature to lower temperature. As long as you remember this, you will not go wrong. So that you know who will gain heat, who will lose heat. All right. So can you tell me, here is whenever we write gain heat, what is the next word? Can you type into the chat? And then lose heat, what is the next word? Can you give me these two blanks? Bella said this question came out in her school examination. All right. Thank you for sharing, Bella. I hope you gotten this right. All right, so can y'all give me the two blanks in the chat? Type your answers into the chat. Gain heat what? Lose heat what? What is the English word? What's the preposition? It's not talking about as when, like, the ice gain heat. Then what is the next word you're right? The ice gain heat. Is it from or to? Okay, so tell me the two blanks. Bella, is your answer for the first blank or second blank? All right, Jerome, well done. Excellent answer for both of them. Give me both blanks. All right, give me both blanks. Right, so I hope by now everybody will know it's gain heat from and lose heat to. So your English sentence is always gain heat from, lose heat to, gain heat from, lose heat to. You don't write gain heat to, you don't write lose heat from. Right, it's always gain heat from, lose heat to. Then let's analyze this. So at first you have a piece of ice. Ice is at 0 degrees Celsius. All right, then there's a surrounding air. All right, air is the surroundings, okay, around the ice. So if I'm going to compare this, can you tell me which one is at higher temperature? Is it the ice or the air? Can you type into the chat which is at a higher temperature? Ice or the air? Which is at a higher temperature? If you have a piece of ice and you leave it on the kitchen table, which one is at a higher temperature? The surrounding air or the ice? Which one at higher temperature? Raiden, if you touch the ice is really cold. The ice has just been taken out from the freezer. All right. So she took the ice cube from the freezer. The ice is very, very cold. So definitely the temperature of the ice is very low, right? 0 degrees Celsius. In fact, the air, right, around Singapore, air should be around 30 degrees Celsius or even hotter. All right, so Raiden, I hope you understand this. It's okay to get this wrong, but don't get this wrong for next year's exam. So ice is definitely lower temperature. So let me write here lower. Then the air here is higher. All right, because the surrounding air is about 30 degrees Celsius or even higher. Singapore is so hot, right? Then the ice you just took out from the freezer. All right, the freezing part of ice is actually, the freezing point of water is at, or the melting point of ice is at 0 degrees Celsius. So 0 is a small number, so lower. Therefore, heat always flow from H, higher temperature to lower temperature. This is how heat will flow. All right, so heat will flow from the surrounding air to the ice. Okay, so heat will flow from surrounding air, you go to the ice. So in other words, the ice will, what will happen to the ice? Ice gain heat or lose heat? Can everybody type in the chat? What will happen to the ice? Gain heat or lose heat? All right, gain heat or lose heat? What happens to the ice? Thank you, Bella. Well done. The rest, what will happen to the ice? Gain heat or lose heat? Since you know the surrounding air is at higher temperature, 30 degrees Celsius, Ice at a smaller number, lower temperature, 0 degrees Celsius. So heat always flow from higher temperature to lower temperature. So ice will gain heat. All right, so I'm going to write it here. So the ice will gain heat. All right, from where? Obviously, it's from the surrounding air. Okay, so ice gain heat. Here is ice gain heat. All right, ice gain heat. So here ice lose heat. That's wrong. Ice lose heat is wrong. So A and D is definitely wrong. It's only left with B and C. All right, then let's take a look at if you put the ice on the table for 1 hour, the ice will melt. After 1 hour, all the ice will melt into water. No more ice, all water at room temperature. All right, so maybe I'll take it as room temperature is at 28 degrees Celsius. Okay, so because here wrote 28 degrees Celsius. All right, now water is at room temperature 28 degrees Celsius. Now you're going to put this water back into the fridge. All right, place the water into the fridge. Okay, and the fridge is very cold. Okay, so here, let me write here. Okay, so here we are going to write air in the fridge. Not air outside. Here, over here, air in the surrounding. Maybe I'll make it clearer. This air is talking about air outside the fridge. All right, air outside the fridge. Here we are talking about air inside the fridge. All right, so we are comparing the air inside the fridge as well as water at 28 degrees Celsius. Now, which one is at higher temperature? Can you tell me, is it water or the air in the fridge? Which one at higher temperature? Basically, you have water on the table and then you put the water into the fridge. So if I'm going to compare water and air inside the fridge, which one is at higher temperature? All right. Okay, thank you, Raiden. Okay, well done. So in other words, the temperature here will be higher temperature. Air in the fridge will be lower temperature. Because fridge is very cold, right? So the air inside the fridge is definitely colder. Whereas water is at 28 degrees Celsius is higher. So heat always flow from H to L. All right, so this is how heat will flow. So heat will flow from the water. All right, heat will flow from the water to the air inside the fridge. All right, so in other words, this water will lose heat because heat is flowing from here to the air inside the fridge. All right, so here will be water loses heat. All right, to the surroundings. Here, surroundings means the air in the fridge. All right, surroundings here means air in the fridge. All right, so the answer is B. All right, any questions so far? All right, there's no question, then we move on. So basically, I will provide some slides to help you in your revision. I know exam is over, but I hope these slides will help you in future. You keep the files, and then you can use these files when you're in primary 5. All right, so heat always flow from a higher temperature or hotter place to a lower temperature or cooler place until both places reach the same temperature. So for example, if you have an ice on your hand temperature is warmer, the ice temperature is cooler. All right, ice is at 0 degrees Celsius. So this is lower. So maybe I'll write here lower. All right, lower temperature, 0 degrees Celsius ice. Okay, then our hand is about 37 degrees Celsius, is higher temperature. So heat always flow from H to L. All right, so your hand will lose heat. All right, but can I add full stop? I cannot, right? I must add one more word. Can y'all fill in the blanks? Hand loses heat. What else should I write? I cannot write hand loses heat full stop. It's not complete. The answer is not complete. Can y'all type into the chat? Thank you to what? To who? Loses heat to the ice. Okay, well done, Bella. To the ice. Okay, another way to write will be ice gain heat. If you write gain heat, it will be from. So ice gain heat from the hand. So please know how to write. Lose heat to, gain heat from. All right, loses heat to, gain heat from. Okay, so always H to L. So please remember that heat always flow from higher temperature to lower temperature. Okay, so this is higher. This is lower. All right, temperature. Okay, so this is how heat will flow. Right, until both reach the same temperature. Then no more heat flow. All right, so I have one more question for everyone that is not in the portal. So Ivan ordered a cold drink. Actually, this could be beer or this could be chrysanthemum tea. All right. So Ivan ordered this cold drink. He noticed that and normally an empty chilled mug taken from the freezer is used to contain the 15 degrees Celsius cold drink. All right. So let's say you are a shop selling cold beer. All right. Let's say you're selling to adults. Children don't drink alcohol. Let's say you're selling cold beer to your customers. Now, beer only tastes better when it's cold. Beer tastes terrible when it's not cold. Okay. So what the restaurants will do is they will put the empty mug, and mug means the cup. All right, mug means the cup. They'll put the cup inside the freezer. Empty one. They'll put the empty mug or empty cup inside the very cold freezer. Then when the customer orders the beer, you are the waiter, let's say you are the waiter, you will take out the empty cup from the cold freezer and then you will fill the empty cup with beer. That will make sure that the beer will remain cold. All right, so now you need to explain how come it's better to pour a 15 degrees Celsius cold drink or cold beer into an empty chilled mug taken from the cold freezer rather than you pour the same beer drink into a mug at room temperature. All right, so what they're saying is if you were to compare, if you put the empty cup into a freezer, it's better. So they're asking you why. All right, putting an empty cup into the freezer and taking it out and putting beer inside is better than if you just take a mug at room temperature. All right, that means an empty mug from the table at room temperature and then you fill the mug with beer. That's not good. Why? All right, so can you think through this and tell me here, all right, whether it's gain heat or lose heat and what is the preposition here. All right, can everybody type these first two blanks? All right, give you a few seconds to think through what is the answer here, these two blanks. Give me the first two blanks first, Raiden. This one, the 15 degrees Celsius cold drink, what heat, what? From the chilled empty mug means cup from the freezer. All right, give me the first two blanks. Bella, here this blank and this blank. The first blank is either gain or lose. Clarice, your English preposition is wrong, but it's a good try, Clarice. Well done, Bella, both excellent answers. Okay, the rest. Okay, let's analyze it together. So imagine you have an empty cup and then you take out this empty cup from the freezer. So in other words, you have 0 degrees Celsius mug because you took out from the freezer. Freezer is 0 degrees Celsius, right? Very cold. All right. Then now you're going to put your drink inside. You're going to pour your drink inside. Now this drink is 15 degrees Celsius drink. Okay. Right. So at first you have an empty cup that you took out from the cold freezer. Therefore, this cup is at 0 degrees Celsius because you took it from the freezer. This cup is definitely at 0 degrees Celsius. Then you pour your 15 degrees Celsius cold drink inside. So you pour it in. We are saying this is better. Why? So let's analyze HL. So obviously 15 degrees Celsius is a higher number. So I put H. 0 degrees Celsius is smaller number, lower. So therefore, it will be this way. Heat always flow from H to L. All right. Remember your HL milk. Therefore, here the drink will lose heat. All right. Loses heat to. We cannot write loses heat from. So this cold drink will lose heat to the mug, which is better. Then my drink will be very cold. All right, the temperature of my drink will be lower than 15. After the heat flow from the 15 degrees Celsius drink to the mug, to the cup, then my 15 degrees Celsius drink will go down to 14 degrees Celsius, even better, even colder drink, which is what I want. All right. Where else, if you were to do another way, which is